Hi all. Let's start with one more topic in transaction layer in PCI. We'll see some terminologies in the transaction layer. Malform TLP. What actually Malform TLP? So Malform TLP, we'll see why it's generated. What are the reasons behind that? We'll see some scenarios. What are the different types scenarios we have to generate Malform TLPs? So what actually happened? Now let us take scenario where you have a RC, you have a EP, you are sending request. Let us assume you are writing data from your RC to EP. Let us assume one scenario, RC to EP. You are writing the data from RC to EP. So specific location, let's assume 0 to 15 address. You are writing data. So while sending from RC to EP, here you will add as a ECRC or a ECRC. Let us assume ECRC you calculated. In receiver end, you will see as some errors in the issue. So you got an error as a receiver end, CRC error. So what happened? Due to that CRC error, what happened? What we will need to understand that the data may changed through this lane. Somewhere it's changed that data. So what happened? Receiver and EP what will happen? It will generate as a message as a malform TLP. That message will generate from the EP to RC side. That message coming from the EP to RC side. That packet will be dropped. Whatever data you are sending from RC to EP side, that data will be dropped. That won't be considered as a EP side. So what happened? You will see as a error as a malform TLP. Maybe some error in the present that we call as a malform TLP. So we'll see some scenarios how different types of malform TLPs will generate. So I added in the slide we have some different types of malform TLP. So what happened due to malform TLP will be generated as a one more topic we called as a advanced error reporting mechanism, AER. By using this mechanism we can generate the malform TLPs. Before going to see malform TLP what happen, we need to enable the advanced error reporting status registers. In the status register we have a 32 bits. 32 bits in that I think 16 or 7th bit we have a enable or disable malform TLPs. If you are enabling that bit, it will be the you will see as a enable, you will see as a malform TLPs if anything comes. Otherwise you won't see any error. Based on that requirements, you can enable or disable to that resistor. You can able to control actually these errors. You can able to control in your ad. You can able to control. If you don't want to consider these errors, just you have to disable the that bit in the status resistors. So we'll see some scenarios where you will understand what actually where actually you will see as a malform TLPs. So one scenario where I already told, you have a RC, you have a EP, you are writing data from RC to EP. So RC, this one is a EP, root complex and endpoint. You are while sending here ECRC calculated, here also ECRC need to be calculated. So while calculating ECRC, maybe some issue ECRC gets failed. So that packet will generate as a malform TLT. That message coming from the EP to RC side. That is a one scenario. Let us take one more scenario. Any error of the error detection in EP side, it silently it will drop as a malform. Here is a one scenario is ECRC error. Maybe any other issue. Maybe the address is not present. Anything issue it comes up, we called as a malform TLT. If data payload length value in header and payload size is different, then it's considered as a malform TLP. Let's take as a length point of view. Let us you are writing uh, 20 words. 20 words of data you are writing from RC to AP. In EP side, if you see any more than 20, so you will see as a more, if you see more than 20 payload, you are adding length is 20. Here also same TLP we got, but you are adding with payload as a 21 or 22. So you will in EP side it will see how much data I can able to see. If you see in more than 20 devices of data, that we called as a Malform TLP. One more point. It's TDBT is enable means ECRC need to be calculated. If not, TLP considered as a Malform TLP. Let us in a TLP header we have a bit as a TD bit. That TD bit indicates whether you want to calculate ECRC or not. Some cases you don't want to calculate ECRC in every packet. So sometimes what happen, you can disable that bit. You give as a 0. If you are enabled on TD bit is 1 means you should be calculate receiver and transmit both side you have to calculate the ECRC. So let's some scenario in transmitter side you give as a TD bit, in header you give as a TD bit is 1. Let us you give that TDBT1 is given, that TLP are sending from RC to EP side. If EP side if not calculated, that ECRC some due to some issue, its ECRC is not calculated EP side, so that automatically it will consider as a ECRC error. So in this way it may be another scenario where here is EP bit is 0, but CRC is calculated in RC itself. TD bit is 0, TD bit is 0, but it's don't the RC don't want to calculate any CRC values. But by default, RC is calculating again from ECRC. Once receiving EP side, TD bit is 0, but CRC values is present. ECRC value is present. So in that consideration also, we'll conclude as a that TLP is a error TLP. We should not consider in EP side. EP will assume as a this is a malform TLP. One more is a data payload cross the maximum payload is called as a malform TLP. Let us assume maximum data payload you assume as a encoding in these values will be give as in encoding in the device control register. How much data you want to send from your transmitter to receiver or say to EP. Let us I want to send a maximum will be the 256 words. This is encoding I done in the device control register, but due to some issue that a link is sending maybe more than 256 packets, more than 256 data in the payload. So in receiver end it will see as a more than 256 devices of data, that considered as a malform TLP. So you should not cross that maximum payload size. MPS settings. This we call as a MPS setting in the device control register. You have to set accordingly how much you want. One more will the maximum read request. When let's say where say you have a RC, you have EP, you are sending the request. I want to read the data. 250 records of data. So EP will send as a completion with the data. So completion with the data means completions whatever data coming from the EP to RC to it should not cross that boundary. 256 words you are giving as a MRRS settings, but you are getting more than that. It will consider as a malform TLP. One more is uh, one more scenario where you have a RC, you have a EP, you are sending the request to read the data from EP to RC side. So you are sending the request memory request, you will get as a completion with the data. Let us I want to send a request with the tag as a 1. Every feed in a transaction layer header we have a second debug, we have a field as a 8 bits tag will be there. Let us I want to use as a tag number 1. You will get as a completion with the same tag, then only RC will got to know like I'm getting as a with the tag as of whatever send a request I got with the same request, I got a data, so it will conclude as a this is the actual data. But due to some issue you will get as a different tag with the same data. So different tag means the RC will assume as a this is not our actual data, so it will consider as a multi-form reality. So in this way, using that tag related, you will get as a one more error. Maximum payload size tag related. So these are the scenarios I added for how to understand how it's generated malform TLP. So this is malform TLP is very important topic to enable the using that advanced error reporting mechanism. So I'm in this video I covered more most of the things related to Malform TLP. By using this Malform TLP, we have to try to reduce these Malform TLPs to increase the bandwidth consideration. So in this video, I explained Malform TLP. If you have any question, please let me know. Thank you.